Hello friends, welcome to the channel. Welcome to the third part, the third series of the chapter Atomic Structure. Let us start with the today's. Now see, today we are going to deal with the Rydberg's formula as well as the emission diagram. First of all, see, in the previous lectures I have told you the energy of nth formula is minus 13.6 Z square by N square electron volt, right? So accordingly, we are going to make the emission spectrum for Z is equal to 1. That means for hydrogen. Now, when we take the value of N equal to 1 for N equal to 2, let me take up to N equal to 3. Now see, what are the value of energies in these cases? First of all, for E1, E2 and E3. See, when we put the formula minus 13.6 Z square by N square is equals to 1, that means minus 13.6 electron volts. Now E2, for E2 minus 13.6 into Z square, that is 1 for hydrogen, N square means 2 2s are 4. That means here it will be minus 3.4, near about minus 3.4 electron volts. Now here it will be minus 13.6 into Z square, again 1 by 3 3s are 9. That means now it will be minus 1.51 electron volts. Now similarly, ahead we will make in the emission spectrum. Now see, for making the emission spectrum, first of all, this is N is equal to 1 for ground state, N equals to 2, N equals to 3, N equals 4, N equals 5. We have to take care that the energy gap reduces as we move ahead. N is equals to 6 and lastly N is equal to 7. Right? See. Now first of all, we are making the emission spectrum. Here see. An electron suppose comes from N equals to 7 to N is equals to 1. From N is equals to 6 to 1. From 5 to 1. From 4 to 1. From third state to the first and from the second state to the first. See now. Similarly, as we move ahead, from N equal to 3 to 2, from 4 to 2, from 5 to 2, from 6 to 2, and lastly from 7 to 2. Now from 4 to 3, from 5 to 3, from 6 to 3, and last from 7 to 3. Now is from 5 to 4, 6 to 4 and 7 to 4. Now is from 6 to 5 and from 7 to 6. Now is the last one, which would be made somewhat like this. Let me connect these. See. Right. Now see, these are given specific names. First of all, let me tell you the names. This one, the first here, this is called as the Lyman series. This is called as the Lyman series. Then is the Balmer series. Then comes the Paston series. Then comes bracket series. Then comes Pfund series. And at the last comes this one is Humphrey series. You can learn this by this L, BP, BP, H. Lyman series, Balmer series, Paston series, Brackett series, Pfund series, and then comes Humphrey series. Right? Now let me also tell you, they lie within particular areas. That means they lie within particular radiation zone. See, this Lyman series comes under the ultraviolet region. Now in NEET exam also it is a number of times asked. This comes under the ultraviolet region. The one which comes under the visible region is the Balmer series. This has come. Visible region is that of Balmer, and the remaining all Humphrey, Pfund, Brackett, and Paston. These all comes under the infrared region. These all comes under the infrared region. Okay. Now this is the emission spectrum. Now let us move ahead. Let me tell you the Rydberg's formula. Now see, we have the Rydberg's formula. In the Rydberg's formula, see, this is not frequency. This is called as the wave number. Nu dash. Wave number, that is inverse of wavelength. That means is equals to 1 upon lambda into r z square into 1 by n final square minus 1 by n initial square. R z square, this is the Rydberg's constant. This is your Rydberg's constant. And the value of Rydberg's constant is 1.097 into 10 to the power 7 per meter. This is in approx value. It is written to be 10 raised power 7 per meter for solving the numericals. Right? Now after this, let me tell you that if we multiply H into C on both the sides, see, let me write it again, 1 by lambda R. For hydrogen, Z will be equal to 1. R into 1 by n final square minus 1 by n initial square. C. If I multiply HC on both the sides, then it will be HC over lambda is equal to R into HC into 1 by n final square minus 1 by n initial square. Now see, this HC over lambda, is the formula of energy. It can be written as change in energy. R into, see, if we open this, it can be written as RHC upon n final square minus RHC divided by n initial square. What we can write is delta E is equals to, this one can be written as E final minus, and this one can be written as E initial. That means delta E is equal to E final minus E. Let me also tell you about the H alpha line and H beta line. See, suppose in the question it is given that calculate the wavelength and frequency of H beta line of Balmer series. For hydrogen atom. See now. Suppose this n is equals to 5, n is equals to 4, n is equals to 3, n is equals to 2, and this is n is equals to 1. So for Balmer, as you know, the initial one is, the state is second. So see, perfect. this line from n is equal to 3 to n is equals to 2, this will be called as the H alpha line for Balmer series. This one from n is equals to 4 to n is equals to 2, this one will be called as the H beta line, and this one which connects from n is equals to 5 to n is equals to 2, this will be called as the H gamma line. So the value of n which we will take here will be n1 can be written as, for H beta line it is written, so n1 can be written as from 4 to n2 is equal to 2 for Balmer series. That means we have to find the wavelength. So we can write 1 upon lambda is equals to r 10 raised by 7. Let me write the direct value. 1 by nf square minus 1 by ni square. That means 1 by 2 ka whole square minus 1 by 4 whole square, which can be written as 1 by lambda can be written as 10 to the power 7. That means 1 by 4 minus 1 by 16. So this can be written as 1 by lambda is equivalent to 10 to the power 7 into. If we take 16 as the LCM, 4 4s are means minus 1. So lambda can be written as 16 divided by 3 into 10 to the power minus 7. Or this can be written as near about approx value 5.3 into 10 to the power minus 7 meters. This can be the value. So this was the concept of H alpha line and H beta line. Now we will continue with a little bit more left concept in this chapter in the next video. Thank you.